The number you have dialed has been changed.
Hello guys, welcome back again to our channel. For today's content, I'll give an experiment to show you the effect of catalysis on chemical reaction rate and the effect of temperature on chemical reaction rate. So here's the first experiment, the power of bubbles. The materials are plastic bottles, warm water, yeast, sugar, balloons, and lastly, the teaspoon. The following are the procedures. First, prepare 2 empty bottles and label the first bottle with yeast and the second bottle without yeast. Put 2 teaspoonfuls of sugar to each of the bottles. Put also 3 teaspoonfuls of dry yeast to the bottle with a label of with yeast. Slowly pour the warm water to the 2 bottles. And then put a balloon over each of the bottles and wait for half an hour. Observation. The first experiment shows the effect of catalysis on chemical reaction rate. Catalysis is a process in which the rate of reaction is influenced by the presence of the catalyst. As you see, the bottle labeled as with yeast has been inflated. Why is that so? Because of the presence of the catalyst that speeds up the chemical reaction. Yeast is a microorganism that contains a catalase and acts as a catalyst. When the yeast is mixed with the sugar with the help of a warm water, carbon dioxide is produced. Nowhere else to go, the carbon dioxide goes up, causing the balloon to be inflated. The other bottle, labeled as without yeast, does not change at all, because no catalyst is added to change the chemical reaction. Second experiment, matchstick soaked in water. The materials are matchsticks, tap water, ice water or cold water, and then the lighted candle. The following are the procedures. First, soak a matchstick in water at room temperature for 1 minute. After that, place the matchstick over a lighted candle enough to light it and observe the intensity or color of the lighted matchstick. The cold water. Soak a matchstick in an ice water for 1 minute. After the 1 minute, place the matchstick over a lighted candle enough to light it and observe the intensity or the color of the lighted matchstick. Observations. First, After lighting the matchsticks, we can observe that the light of the matchstick soaked in the tap water is brighter than the matchstick soaked in the cold water. Also, the chemical reaction rate of the matchstick soaked in the warm water is faster than in cold water. The reason behind that increase in temperature is also the increase of the reaction rate because of the disproportionately large increase in the number of highly energetic collisions. The temperature on warm water is higher than the temperature on cold water. Since the warm water has a higher temperature, the molecular energy level is also high, causing the reaction to be faster than the other.